As for our coding part, Oscar did a great job explaining the goals of the coding in the beginning. Other than just calculating the ammonium consumption rate in the three rivers, we also give the user an option to buy gel from one of the provided gel companies. And he also explained the input variables, which has the biomass data, the oxygen concentration data, the ammonium concentration data, and the price data of the companies. He explained the intermediate and constant variables, which are all measured by the lab. And here are the output variables, and Rn is the net conversion rates of the nitrogen at time t as a vector. Output table is a matrix that has the Rn and its corresponding time point. And pricing is the price of the gels with different sizes. So the programming started with the housekeeping program, and then we input all the constants that are used in the equation to calculate the consumption rate of the ammonium. Then we input all the data we need, and also we created the list of the companies for people to choose. And then we start with the while program. So at the end of the program, people can restart the program using the menu function. And first we ask the users to choose a river they want to look into, and if they do not choose a river, we will ask them to re-choose one. If they choose not to choose a river, we will terminate the program. And if they want to choose a river, we will re-ask them which river they want to choose. And then, based on their choice, we will extrapolate the river data we need to use to calculate the consumption rate. Because data that's used in the equation are all SI units, whereas the data of the concentration of nitrogen and ammonium from the data files are in milligram per liter. So we have to convert them from milligram per liter to moles per cubic meter. In the end, we need to take the average of them because they were taken during a period of 6 months. Then we create a final matrix that has all the consumption rates and their corresponding time period. Then we output our data with the choice river, the time point, and the consumption rate, and we use a for loop to output our data. And then we ask the user to choose a company they want to buy gel from. And if do not choose one, the program will terminate automatically. They choose a company or use string comparison to find the name of the company, and then we use a find function to find the rows and column of the company in the data file, and then we find the corresponding pricing of that company. Then we output the pricing of the gels in that company using the same format. Last, we'll plot a graph that has the time intervals and the corresponding ammonium consumption rate. And in the end, we have the menu if the user wants to restart the program or not. If we run the program, it will first ask us about which river we want to look into, and if we choose Pulaski Highway, here we see give us the time points of the growth and their corresponding into consumption rates. And next will ask us which gel we want to buy, and if we choose Sigma Aldrich, will give us the price of the gel and their corresponding mass of the gels. And also here's the graph that has time intervals and the nitrification rates of the biomass. And also the menu will ask us if we want to see data from another river, and if we choose yes, it will close the graph and ask us which river we want to choose again. This time, if we do not choose a river, it will ask us if we want to quit or not. And if we choose no, it will re-ask us which river we want to choose. Here, if we choose Havel Road, it gives us the data of the Havel Road, just as give us the data of the other river. And they will ask us again which company we want to choose. And if we do not choose a company, it will terminate the program automatically. And if we run the program again, it will ask us which river we want to choose. If we do not choose a river and we say yes, we wish to quit, the program will terminate automatically. And if we run the program, it will ask us which river we want to choose. Let's say Mountain Pleasant. Give us the time intervals and its corresponding consumption rate. And we choose a company. Give us the price and the mass. And if we choose no, it will terminate the program automatically. And the limitation of this program is that it doesn't have a user input function. So if another lab has their own data and they wish to input into this program, they have to modify the data from the original data file, which is kind of difficult. But this kind of model helps lab members to simulate their products and the data they got from their lab measurement into real life. So they don't have to go into real life situation and measure it again. They could just simply input their data and they could get a corresponding output in a real life situation, which is really helpful for lab researchers.